Welcome to Brain Vision.
Okay, question 42. A 50 kilogram box rests on the floor. The coefficients of static and kinetic friction between the bottom of the box and the floor are 0.70 and 0.50 respectively. What is the minimum force a person needs to exert on the box to start it sliding? Okay, this is part A of the question, so we're just going to make a few notes here. Mu s is equal to 0.7 and mu k is going to be equal to 0.5. And so at the limit, we're going to have to take the idea that static friction is overcome. And hence the force of friction when static friction is overcome is equal to the coefficient of static friction multiplied by the normal reaction force. Friction will resist motion and will effectively resist against any force that is less than the critical force required to move it. But in this case, we're at the limit, so we're going to push at that point. And hence, we just need to multiply the coefficient of friction by the fact that we're pushing on, let me just remind you, it's a 50 kilogram box. So to overcome that, we're going to have to take 0.7 multiplied by 50 multiplied by 9.8, which is, if we put it into a calculator, equal to 343 newtons. So this is part A of the question. That's the force which we need to use to start moving the box. So after the box starts sliding, the person continues to push it, exerting the same force. What is the acceleration of the box? Well, in this case, you are pushing with a force of 343 newtons, and so your net force is your force that you're pushing, subtract off the force of friction, and this is equal to ma. So the net force is equal to ma, and therefore you take the force that you're pushing with, 343, and you subtract off the force of kinetic friction, 0.5, multiplied by 50, multiplied by 9.8. So this is the force that's resisting. And finally, this is going to equal ma, which is your 50 multiplied by your a. It doesn't take a genius to then say, let's divide the whole left-hand side by 50 to have our acceleration. And therefore our acceleration, putting this into a calculator, remembering 343, subtract off half of 50 multiplied by 9.8, dividing the whole thing by 50, we get an acceleration of 1.96 meters per second squared. Okay, that's the acceleration of the box here. And that's because once we've overcome static friction, kinetic friction takes over, and its coefficient is usually less, which means that the force that we're now overcoming is serving to be greater than the frictional force that is resisting our motion. Hence the net force is not zero, and we do have an acceleration. And that's question 42.